Hi Calculus 1 students. In this video, we're gonna consider a piecewise function, and typically the two questions that you will be asked are, what is f of 3? So, okay, notice first that 3 is actually the junction value of the function. So let's label it in purple. There you go. I'm talking about this 3 right here. What is f of 3? And then next question is we want to evaluate the limit as f of x as x is approaching 3. So sorry for the twisted tongue. First question is easy. Well, okay, it's a little bit tricky, but it's easy once you understand it. So what it means, f of 3, is the value that the function takes when x is exactly 3. So the value of f of x when x is exactly 3, okay? And as you can see, it is undefined, right? We don't have any equal sign going on over here. So reading the function, it's undefined. At x equals 3, okay? Because there's no inclusion symbol. Now, the reason why it needs an inclusion symbol is obviously because it's at the junction, right? It's the place where it changes formula. Otherwise, we would assume that it's defined wherever we can punch 3 in and it works. But in this case, because it's the junction value, we need to specifically include it either in this formula or in this formula. And since it's not the case, the function is undefined. So this is the answer. Actually, I'm going to include a little bit of the explanation. But now we would like to evaluate the limit as x is approaching 3 of f of x. And as you can see, again from the function, because it's a junction value, the formula to use depends on how x is approaching 3. So the formula to use depends on if x is approaching 3 from below or x is approaching 3 from above. And because of this, we need to evaluate both one-sided limit. Okay, so let's get going. First, let's have a look at the limit as x is approaching 3 from below of f of x. So it is the limit as x is approaching 3 from below. Okay? And the idea is to determine which formula. The fact that x is approaching 3 from below means that x is below 3. And this selects the formula to use. We will use this formula. Now, you might be worried about the fact that x could be smaller than -1. But by saying that x is approaching 3, it's far away from -1. Like it's getting to 2, 2.5, 2.9, 2.99. So always look near when x is equal to 3. So you don't have to worry about this, in other words. But it does tell you, since x is smaller than 3, that you have to use the first formula. So here goes. You have x minus 3 divided by the square root of x plus 1 minus 2. As you replace that, you will get 0 over, and there you're going to get 3 plus 1, so 4. So square root of 4 is 2 minus 2, 0. So you're going to get 0 over 0. Now, at this point, first see that x minus 3 is a problematic factor. So we're kind of happy. We don't have anything to do at the top. What we have to do is at the bottom. Okay? So we would like, remember, first option is to try to factor, but we easily see that we cannot factor because we have a root. So idea is, let's get rid of the root. Let's rationalize. So we multiply by the square root of x plus 1 minus 2 over the square root of x plus 1 minus 2. And just as a safety net, let's put the brackets. Okay, so we have brackets around this. We have brackets around this as well. So this means that we have here x minus 3. And the top, we are not concerned because, oh, oops, I messed up my conjugate. It's plus 2. But, okay, so the reason why I saw my mistake is because I knew what I was doing. So the top, we're not concerned because as we replace 3, we're not going to get 0. And the reason we know that is because we know that this is giving the 0. So we know that adding 2 instead of subtracting 2 is certainly not going to give 0. And the problematic factor is already here. This means that at the top, we're really just not doing anything. Whereas at the bottom, again, we need to use the difference of squares formula. So we go. This squared minus that squared. And you have square root of x plus 1. And here you have simply 2. So let's try actually the next step. So x minus 3, x plus 1 plus 2. And then we have here x plus 1 minus 4. So as you expand this, you will turn out to have x minus 3. Which means that you won. Because you cancel this with that. Okay, and now just to save space, as you can see, I don't want to finish the limit up here. I trust you to do this. You're using direct substitution. Okay, so this is canceled. You replace 3 in here. So you've got the square root of 4, which is 2, plus 2. So the final, the result of the limit from below is 4. All right, I will erase this now. Oh, I kind of need the function. So, okay, I'll just take this piece right here. Or, oh, better idea. I will erase this part. So now the deal is to take the limit from above. So the limit as x is approaching 3 from above. So as you can see now, it's the opposite argument that's going on. So if x is approaching 3 from above, it means that x is larger than 3. Like it's going to get to like 3.5, 3.1, 3.01, 3.001, but it's going to stay above 3, which means that it's now this formula that we need to use. So copy it, x squared minus 4x plus 7. And I'm quite happy. This is an easy part because substitution is guaranteed to work here. We have, I feel bad of doing this, but let's just do it for the purpose of clarity because direct substitution is actually working. So it's actually not bad I do it because then the calculations are much simpler. So we have here 9 minus 12, which is going to give, wait a minute, 9 minus 12 is negative 3. There you go. Plus 7. So it's going to give 4. So as a conclusion, remember we were asking the limit as x is approaching 3. So as a conclusion, the limit as x is approaching 3, actually, okay, so I'll just color code the two-sided limit in purple, but the rest I will do blue as usual, is also equal to 4. And remember, this is because both one-sided limits match. All right, there you are, guys. I hope that this helped. The big point is really to remember that if you're asked a limit when the function is changing formula, it forces you to take both one-sided limit and to use the corresponding formula each time to see if the two pieces agree or not. I hope this helped. Have a great evening. See you next class.